Eulachon, also known as hooligan in Alaska, or Eulachon, also known as the candlefish. They're a member of the family Osmeridae, which are smelts.
There's a lot of significance surrounding this fish, and because of that, we would like to know more about how they're doing. We don't have a good baseline for where the population is right now that we can use to compare them to how the population looks in the future, and there's plenty of reasons to be concerned about how the population will fare.
It is important to study hooligan because they are forage species, so they depend highly on plankton. That is their main food source, and other species depend on them.
So they're low on the food chain, just above the smaller things that they eat, and feed a lot of much larger species from marine mammals, including seals, sea lions, whales.
And as a result of being a forage species, they're highly dependent on ocean conditions.
Given changes like climate change, we know that hooligan are very temperature dependent, and that they have a small range of temperature that they can tolerate for spawning, and that their eggs will hatch at different rates depending on the temperature of the river at the time that they're laid and how long it takes them to incubate.
We started fishing our hooligan trap, which is a modified fight trap. It is a trap that the fish will swim up, and they'll swim into the wings, and then it'll direct them into the trap, and then they're stuck in there. And what that allows us to do is collect a catch per unit effort. So we record the time and how long the trap was fished and the number of fish that were caught, so we can tell how many fish are there.
And so the next step in the process is to collect larval fish and eggs that are drifting out. And once they hatch, these tiny little larval fish that are like the size of an eyelash basically float downstream back toward the estuary. And it takes them a little while because they're just drifting with the flow of the water. And what we do then is take a raft out with plankton nets, just these fine mesh nets, towed behind, and capture the larval hooligan and the eggs. We take that information, we figure out and have the tedious process of counting the eggs and looking at tiny hooligan larvae through a microscope to make sure that they're not something else and counting them. And then we take that number and compare it to the weight of the females that we captured earlier during the adult sampling, so that we can understand how the body mass, how the weight of the females matches up with the number of eggs in each female, and that gives us an understanding of productivity, or how fertile and how much reproduction can be expected.
Basically, in that water sample, you can look for the DNA from a certain fish, and then you can tell if they're there or not, and then you can tell how much DNA is in that water. So eventually you can figure out if you have a run size estimate from like our catch per unit effort, so the trap, and then you can compare that to the eDNA amounts that are in the river. So eventually what we'd like to be able to do is just use eDNA, and it's a very cost-effective way to sample a fisheries population.
It's much preferable to know what your species looks like and to see how the population health is doing before it gets to the point where it requires that much effort to keep them stable and to keep them viable. And so monitoring species before being proactive and monitoring species before you see them starting to decline is really critical.